really just relying on x, y, and r definitions. And if you know that, we can figure out a lot of different things. So pictures are optional on these. Some people that really makes a big difference for, some people don't need them. And I don't care, whatever works for you. I have an angle in quadrant 3, and tangent is 8 over 5. Right. What is the ratio for tangent? Do you remember in terms of x, y, and r? Tangent is y over x. So at this point, I know x is 5, and y would be 8. If you want to draw a picture, you can. We're in quadrant 3. If you're in quadrant 3, does it make sense for x to be 5 and y to be 8? No. What would have to be true about those? They're both negatives. And the reason my tangent was positive is because a negative divided by a negative is positive. So the quadrant is what told me, okay, if I'm going to have x negative 8, y negative 5, those things, because of that third quadrant, had to be negative. Alright, I need x, y, and if I'm going to find my other trig functions, we'll need r. So to find r, you can use the definition square root of x squared plus y squared. If you choose to draw a picture, a lot of people just think back to Pythagorean theorem. That's the same thing. That's where r comes from. Square root. That's the same. Not that it matters, but negative 5 squared plus negative 8 squared. So r is always positive. I get the square root of 89. I want you to reduce that if at all possible. Can we break down the square root of 89? No, so we just leave it as radical 89. So if you've drawn your picture, you can use that. Otherwise, you've identified what x, y, and r are going to be in the problem. So then we can give the rest of our trig functions. So remember I told you when you write it, when you do sine, make sure you put a theta with it. What is the definition of sine? Over r, so negative 8 over radical 89, or if you're using your picture, sine opposite over hypotenuse. We can't leave the radical on the bottom, so it's negative 8 radical 89 over 89. If we know sine, then we know it's reciprocal, cosecant. So we just flip it, so negative radical 89 over 8. Easier to flip the one before you move your radical around. What's the definition of cosine? My r is radical 89, or if you did a picture adjacent over hypotenuse, so negative 5 radical 89 over 89. Reciprocal of cosine is secant, so that would be negative radical 89 over 5. And tangent, I already gave you, so you don't have to list it again. If you did, I wouldn't count off. Reciprocal of tangent is cotangent, so x over r, or if you just flip tangent, you get 5 over 8. Questions? So if I gave you more of those problems, you guys could figure it out. The last thing we want to talk about are some different identities, some properties with our trig functions. So the first one's Pythagorean identities. We're going to look at for the first time today, and I'll talk about them a little bit, but we will hit these a lot more later on. So right now, it's probably not going to be your go-to method for solving them. It works, but we'll use it much more later. Now is just a good time to talk about it. We know in a right triangle, x squared plus y squared equals r squared. If I went through and I divided each of these things by r squared. Okay, we know in an equation it's legal to multiply or divide by whatever you want as long as you do it on both sides, right? So if I do that, x squared over r squared, that's like x over r squared. Y squared over y r squared, so y over r squared. R squared over r squared is 1. That actually turns into a very important trig identity. What is x over r? So it's cosine squared theta. Plus, what's y over r? Sine squared theta equals 1. And I usually tell people this is one of the most important trig identities. Cosine squared plus sine squared is equal to 1. There are 2 other variations of this. For now, we're not going to use them a lot. If I wanted you to use one, it would be this one. So if I put a question on the test and told you to use this identity, it would be that one. The other 2 we can get the same way. So if you think about what we did here, we started off dividing by r squared. So to get our other 2 formulas, we're going to start off dividing, but we divide by the other variables. Okay, so if I went through and I divided everything by x squared, for instance. So back to this original identity. X squared divided by x squared. So x squared over x squared is 1. Y squared over x squared would be y over x squared. What's r over x squared? So this identity is 1 plus, what's y divided by x? 1 plus tangent squared theta equals, what's r divided by x? So 1 plus tangent squared theta equals secant squared theta. The third one, so we divide by r squared, we divide by x squared, we would have to divide by y squared. X over y squared. Y squared over y squared is 1. So it's r over y squared. What is x divided by y? Cotangent squared theta plus 1 equals r divided by y. So these 3 formulas are called the Pythagorean identities in trig because they all started with the Pythagorean theorem. x squared plus y squared equals r squared, and we manipulate them. They are useful. We will come back to them. For now, the only one that I would expect you to use is the first one, sine squared theta plus cosine squared theta equals 1. If I asked a question on the test, I would be expecting you to use that one. Now, the others, if you like them, you are welcome to use them at any time. So they're free for you to use, but I won't require you to use them. All right. We could even, verify that on some of your old problems if we went through and we did, sine squared plus cosine squared. Those would work out to be 1. So the identity holds true there. The other one that is helpful is we have some quotient identities. If I took sine divided by cosine, what is the definition of sine? And the definition of cosine is, we know from algebra, if you want to divide fractions, you flip and multiply. If you do that, your r's canceled, and you're left with y over x, which is, so this tells me tangent is equal to sine over cosine. So these trig functions are all related. We already know the reciprocals. If you have sine, you just have to use the reciprocal to get cosecant. Reciprocal of cosine is secant, and so forth. But now we also know if I divide sine and cosine, I get tangent. And if I did it in reverse, what if I did cosine divided by sine? What do you think that one would turn out to be? Cosine is x over r. Sine is y over r. So if you flip and multiply, r's cancel. We have x over y, which is, because they're reciprocals. Reciprocal of tangent is cotangent. So if you flip sine over cosine, you get cosine divided by sine. This is just showing us a few more of the relationships that we might want to use. Any questions there? So let's look at the last couple examples. I want to find cosine and tangent. So I didn't ask for all 3 trig functions. Given that sine is negative radical 2 over 3, and cosine is greater than 0. So we have 2 options. Could we do this like our first problem? Yeah, if you go back and find x, y, and r. We know that sine, what's the definition of sine? Y over r. Which one would get the negative? R has to be positive no matter what. So the y would be negative radical 2. The r would be 3. I didn't tell you the quadrant, so you would kind of have to figure that out. We do know that cosine is positive. So cosine is x over r. We know r is positive, so x would have to be what kind of number? I want cosine to be greater than 0. So cosine has to be positive. And if r is positive, that means x would also have to be positive. So you could solve for your x and you would need a positive number. I'm going to show you two different ways of doing this problem. So this is the way like what we were doing before. X squared plus y squared is equal to r squared. Negative radical 2 times negative radical 2 would be a positive 2. X squared equals 7. So x, when you solve for square root, we have plus or minus, but we know if cosine is going to be positive, x has to be positive, so it would have to be a positive radical 7. If you wanted to draw a picture, your x is positive, your y is negative, so we would have to be here. Now, we have lots of different tools so far. We can just write x, y, and r. We can draw ourselves a picture and use SOHCAHTOA. We can also use trig identities. If I want to finish the way I have, if I wanted cosine, cosine is x over r, radical 7 over 3, or if you're looking at a picture, adjacent over hypotenuse. Tangent, y over x, or opposite over adjacent. And to move the radical 7, so if you multiply that, you get negative radical 14 over 7. And we would have our answers. Most people prefer this just because we've already been doing that. It uses x, y, and r, or your picture, whatever you're most comfortable with, so it's really nothing new. I just didn't ask for all the functions. The other way of doing it, the hardest part about this is figuring out your signs, because I said cosine had to be positive, so you knew x had to be positive. We could use our Pythagorean identity we wrote down. Cosine squared theta, cosine squared theta equals 1. And then we plug in what we know. So we write it as sine squared. That just means you take the value of sine and square it. And we were told sine was negative radical 2 over 3. So if I square, negative radical 2 times negative radical 2 is positive 2. 3 times 3 is 9. I subtract over my 2 ninths. 7 ninths. Square root with that plus or minus. But the problem told me cosine had to be greater than 0, so that means I have to have the positive root. And I can't do the square root of 7, but the square root of 9 is 3. So then we just use our formula. If I wanted tangent at this point, we could use the for the quotient identities. We know tangent, we said was sine divided by cosine. Ah, thank you.
And yes, they are.
So if we divide, we were given in the problem that sine was negative radical 2 over 3. We found cosine to be radical 7. 3. So divided fractions, you flip them by 5. Negative radical 2 over radical 7, or if you get the radical off the bottom, negative radical 14 over 7. So same answer as we did above, just a different way of getting there. In general, I don't care which way you get there as long as you can find the answers. So whatever you like. Most people prefer going back to X, Y's, and R's because we've done that more. But there's always a few people that like the identities, so you're welcome to use those now as well. What questions do you guys have for me? Okay, so here's a problem. I want you guys to try it. Then we'll talk about it, which is just fine. Definition of cosine is? So we know the R has to be the positive. So like X is the one that gets the negative. And then if you're in quadrant 2, we have to decide, would Y be positive or negative? In quadrant 2, that X is negative, but Y would be positive. So if we did X squared plus Y squared equals R squared, just kind of back to the Pythagorean theorem. So negative 7 squared plus Y squared, 25 squared. Y squared is 576. Square root plus or minus, but we know if we're in quadrant 2, the Y would be a positive, so we get Y to be positive 24. Okay, so then I asked for cotangent. So you can think SOHCAHTOA, or you could go back to your definition. Definition of cotangent is X over Y, so reciprocal of tangent. So negative 7 over 24. And I also asked for cosecant. So that's reciprocal of sine. Sine is Y over R, so it'd be R over Y. So 25 over 20. Is that okay? This is the assignment that was up here the other day. Did it stop at 58 is where I told you probably you guys could work to. So you should be able to finish that now.